Thanks for coming to my talk. Today, we're going to take a look at metaprogramming in JavaScript, and specifically the feature called proxies. So I'm Eirik, and I'm an independent consultant, and I do a lot of JavaScript training, and mostly I'm addicted to JavaScript, so that's pretty much what I do. And I'm also very fascinated by metaprogramming. And when I hear the word metaprogramming, I think of these guys, like wizards doing magic. At least that's what it feels like when you try out metaprogramming the first time. And this also seems to be embodied in one of my favorite books, which is this book, Structure and Interpretation of Computer Programs, which uses a language called Lisp, which is a language that is very suited for metaprogramming. And you can also see this in their, you can see that they're using this wizard here as well. They have this thing called the meta-circular evaluator, and there's this wizard doing things to it. And JavaScript is actually in many ways very similar to Lisp. It has a lot of the good parts from Lisp, except it's not homoiconic, which is this very mystical term, which I won't be mentioning anymore because it's not relevant. So metaprogramming, I did a Wikipedia lookup, and they have defined metaprogramming to be the ability to treat programs as data, and the ability to read, generate, analyze, or transform other programs, and even modifying itself while running. So what are they really referring to when they're saying all this, these things? So one of the staples of metaprogramming is macros. And what macros does is that it enables you to create your own language constructs and your own syntax. So here's an example of a metaprogramming library for JavaScript called Sweet.js, where I define some syntax, and if I use that syntax, it will be expanded to whatever that syntax compiles to. So this is an example of doing macros in JavaScript. So here I've created some of my own syntax, but you can also use this to create your own operators. So let's say that you wanted to have a different way of handling promises, of chaining promises. So I'm creating some sort of operator here so that I can write code that looks like this, because I think that this is a better way of expressing chain promises. So this is just an example. I don't actually use this, but you could use this to create a better developer experience for yourself. So all of this macro stuff happens during compile time, meaning that all of this happens before any of your code runs. And a lot of languages also have this separate step for macros called macro expansion time. But the important thing is that all of this happens before the code ever runs. So the other part of metaprogramming, another branch, is called reflection. And reflection has some sub-branches. One of them is introspection, meaning that code is able to inspect itself. Self-modification, which is pretty self-explanatory, meaning that there's code that can change itself. And then there's this thing called intercession. Intercession, the definition of the word is acting on the behalf of someone else or intervening with someone else. So intercession then means that it's code that can make decisions based on itself. So an example of introspection in JavaScript could be that we have an object here, which has some properties, which again has values. And then I use this method here called object keys to see what kind of keys exist on this object. So I've just inspected, the code has inspected itself while it's running. So that's just a simple example of introspection. And then you have self-modification. So we can imagine that we have just a simple function here that is a sum function, but it's a bit grumpy because it usually returns the sum of the arguments. But if you ever pass a first argument that is larger than 5, it rewrites itself to only ever return 0. So if I run this with 1 plus 1, it returns 2. If I do it with 10 plus 1, it returns 11. But all of the preceding times I call this, then it's just going to return 0. So it changes itself during the runtime. And then you could do very simple intercession in JavaScript as well. So if we have an object which has a property, we could use this feature called Object.assign property to say that we want to define a new property on this object. And we want to define a getter for that property, where we say that if the health property here is bigger than 0, it's going to return a string fit like a champ. Otherwise, it's going to return hurt badly, based on the health of this hero. So if I try to access hero.status here, that will be a string fit like a champ. But this sort of intercession in JavaScript is very limited, not very flexible, because you have to be very explicit about which fields should have these special properties. But the important thing about all of this is that it all happens during runtime. So this happens while your code is running. So now that we know what the most important parts of metaprogramming is, we can ask ourselves, why is this useful? Why do we do this? So I had a hard time coming up with a concise answer to that, but I did a little Wikipedia Google again. And it said that in some cases, this allows programmers to minimize the number of lines of code to express a solution, and thus reducing the development time, which seems pretty nice. But I think that the main thing that metaprogramming enables is that you want to have the ability to express and model your problems in a way that makes sense and which is as expressive as possible. Because what we want is really developer-friendly interfaces so that you could use metaprogramming to create all of these interfaces that you would like to have. And you could build these higher-order abstractions from it. So a general higher-order abstraction or interface that we're used to from the web is proxies in the form of proxy servers that are placed in front of a set of web servers. So a proxy server might be placed in front of one or more servers, and it's there to abstract away some sort of complexity. It might be rules for authentication, it might be some sort of logic for redirecting and so on. But the main thing is that the consumer can't see a difference between the proxy and an actual server. It's supposed to be transparent to the consumer just to provide a single interface to the consumer. So the proxy has the same kind of methods that a server has. And different use cases for this might also be like load balancing, compression, caching, and so on. Everything that you want to abstract away from the client. So this is a very specific use of proxies in web servers, but there's no reason why we can't generalize this and say that we could have a proxy that we put in front of one or more just more general objects. So an object has different properties that you can read. You can get something, you can set something. It might have methods that you can apply, and so on. So again, this is all about providing a better interface to program against and to interact with. So in JavaScript, the specification for this new type called proxy has existed for a long time, as a specification, that is. And it's a part of the ECMAScript 6 specification. It's its own type, and this is the feature that enables you to do this advanced type of intercession in JavaScript. Because what it enables you to do is that you could define custom behavior for these fundamental operators, fundamental operations like property lookup, assignment, enumerating, and function invocation, and so on. So all of these fundamental things that you can do in the JavaScript language. And because of this, there is no viable way to transpile this so that most of ECMAScript 6 is just syntax sugar. You could just use Babel to transpile it, but you can actually do that with proxies because it changes the fundamentals of the language. But fortunately, now the support has become really good, so you can actually use this. So fairly recently, the support has gotten really good. So let's have a closer look at this proxy thing. So the proxy has its own constructor. And the constructor takes a target object and a handler object. And this target object could be any type of object. It could be just a regular object. It could be an array. It could be a function. It could even be another proxy, so that this could be recursive. But the important thing is that anything that is an object could be the target of a proxy. So the nice thing about JavaScript is that arrays and functions are just objects underneath. Another thing about the proxy is that it's completely transparent, meaning that if you take a type of the proxy, it'll always return the type of the target that you passed to the proxy to create it. So there's no way for the consumer to know that you are using, that you've been given a proxy. And then there is the handler object, which is the second argument to the proxy constructor. And this handler is an object that contains these so-called traps, traps for operations on the object. So any type of operation that you could do to the object is something that you can trap in this handler. So an example here is with a get trap, where I'm saying that if you try to get something from this object, you should check if this property that you're trying to get exists on the target object. If it does, you'll just return that. Otherwise, you'll return 37. So if I make a new instance of this proxy with just an empty object as the target, and I set the property A to 1 and then the property B to undefined, if I log out the result of getting A and B, I'll get 1 and undefined. But if I log out the result of checking if the object has the key C, it'll give me false. But if I try to log out the C property, it'll log out 37. Because it doesn't really have, it doesn't have the C property, but we default it to 37. So that's just a simple example of trapping operations to an object. And there is, as I said, a trap for any type of operation that you can do to an object. So you can trap the get operation, the set, the has operation, which is the operation that is triggered when you use the in operator. And you have construct. So if you try to construct a new instance of this object, you can trap that by using the construct trap, and so on and so on. So any type of operation that you can do to an object can be trapped. And there's also this new API included together with the proxy, which is called the Reflect API. And the Reflect API is an API that has a method for any type of operation that you can do to an object. So if I have an object here, I can use reflect.get to pull out the health property of the hero. So you could, of course, say that, but why do you need that? Because you could just access it directly. But the point of this Reflect API is that there is a one-to-one match to the proxy traps, so that if I wanted to define a proxy that is just defining the default behavior of an object, I could put in the corresponding reflect methods into all of the different traps. And there's also a special type of proxy, which is called a revocable proxy. So if I create an object here and I want to proxy that with a revocable proxy, I could use the proxy.revocable method. And then it takes the same arguments as the proxy constructor. But instead of just returning a proxy, it returns the proxy and a method that you could revoke this proxy with. So if I try to access proxy.name here, it'll give me the name. But if I revoke this proxy, it will throw an error the next time I try to access something on this proxy, because you're not allowed to do that anymore. Which pretty much then makes the proxy useless. So a lot of this metaprogramming type that you could do with proxies is available already, as we saw with object-defined property and object keys and so on. But the main thing about proxies is that you can now overload operators that are fundamental to the language. You can overload how the dot works, how the equals works, and how function invocation works. So now that we have introduced the important stuff about proxies and the Reflect API, we could look at some simple examples of how you would use this proxy for something useful. So one popular example to look at is validation. So we could make ourselves a function that takes an object and then takes a set of validations that you're supposed to do on that object. We could return a new proxy of that object that we passed. We can say that we want to add a set trap, so whenever you try to set something on this object, it's going to be trapped by this proxy trap. And we'll assume that this validations object here is just an object that contains a function for validating whatever key it belongs to. And it'll either throw an error or just return true if nothing is wrong. So we'll just validate the value that you're trying to set, and then we'll use reflect set to set the actual value, and then we'll just return true because that is the default behavior of using the equals operator in JavaScript. So then we could make some validations here. We could say that we want to validate the age property and we want to validate the name property. And for the age, we'll just check if there's a number. Otherwise, we'll just throw an error. And for name, we'll just assume that this is supposed to be a string. Otherwise, we'll throw an error. So with this, we could now have dynamic validation of objects. So if I create a new object here that is a result of wrapping it in the validate function with those validations that we made, I can set the name and age here to a string and a number, and nothing happens. But as soon as I try to set the name to a number here, it'll just throw, telling you that this is not allowed because it has to be a string. So this is something that would have been really hard to do without proxies dynamically like this. And then another popular example is debugging and logging. So we could make ourselves a function where we log every access to the object. So every time you try to get some field of an object, we could log that. So we can create a new proxy, and then we could have a getter trap. And whenever you try to get something from that proxy, we could log out that you've tried to access a certain key, and then we could pass a second argument here if you wanted to have some kind of string reference so that you can know which object that you were, which was accessed. And then we could just return the result of using reflect get to get the actual key on the target object. So if we wanted to use this, we can make ourselves an object, and then we could make a proxy where we pass that object into that function, give it some kind of reference, and if I try to access age now, it'll just log out accessed age on ABC. Or if I try to access the name, it'll do the same thing. So the nice thing about this is that you're able to wrap functionality around objects without the objects knowing about this. And until recently, we actually we used to have a specification for observables in JavaScript, which we don't anymore because that was revoked for various reasons. But with proxies, you could actually pretty easily make these observable objects yourself. So we could make a function here that makes an object observable. So it's a function that takes an object and then a function that's going to be called whenever something changes. So we could make a new proxy. We could add a setter trap so that whenever you try to set something on this object, we can do something. We'll just do the regular thing of setting whatever value you try to set on the object, and then we'll call the onChange method with the key that you set and the value. And we can do the same thing here with the delete trap. So if you delete some property from the object, we want to have a notification about that as well. So now we could use this. We could have an object here, and the main difference between this and the original object observe is that you'll have to overwrite the original object because it'll only trigger if you try to access or change something on that observable object. So if I just wrapped around observable here and changed something on person without overriding it, nothing would happen. So that's one of the drawbacks. But now you could change something on this object and it will trigger your onChange method. So that's observable objects, which could be useful in a lot of situations. And then I found this example here by a guy named Keith, who used proxies to make this DSL, which is another thing that you could use proxies for. So this is a URL builder, meaning that we could use the fundamental operations of an object to just build dynamic results. So we could create an instance of this URL builder by giving it the first argument, which should be the domain. And then we could just start to say that we want to use the Google URL builder. We want search products, bacon, and eggs. And then as soon as we call this as a function, that will return an actual URL. So again, these are pretty simple examples. And I would say that, yes, this is nice, but is this useful? I would probably say that, yeah, cool, but I'm probably not going to use any of this. So I haven't really looked into proxies for a while, but I've been on a project now for about 8 months where I've finally found a very real-world use case for it. And in this project, we have a lot of real-time data. A lot of real-time data that might look something like this. We have a lot of collections. Let's say we have a set of stories, which is just a large array of different stories. And then we have a large array of people here. And if you look at these data structures here, you can see that it's just plain, this is plain serializable JavaScript. But there is a lot of references here, so that we have a set of stories here where every story refers to some author. Every story has an author. Every story has an array of people that have liked this story, people who have read this story, and so on. And they all implicitly point to some other collection. So there's a collection of people as well. And those people have authored stories, and they have read stories, and they have liked stories. So this connection is in both directions. So you might say that this is a sort of graph-like data. And the graph looks sort of like this. It's just a very big object with a lot of collections, and all of the collections have references to other collections or the same collection. So in this project, we're bound to this data format. But what we really want to do is be able to access this graph here, this JSON graph, very deeply. So I want to be able to say that I want to go into this graph. I want to pull out the first story, and I want to find out who of the people liked this story, and then I want to find the name of the first person that liked this story. And you might imagine that this goes deeper as well. So another example is that I want to go into the first person, and I want to find out yeah, maybe it's supposed to say stories there as well. So I want to find the author, and then I want to find out the likes, and then I want to find the name of the first one. So the way you could do this is, first of all, you could do this very explicitly, just very naively, so that you could go into the graph. You can pull out the first story from the story collection, and then you can find all the references to people there, which will just be strings. And then I could map all of those. I could say that, okay, take all of those strings, and then for each of those strings, go into the graph again, into the people collection, and then find the correct person, and then map that back to our results. And then we could use that to find the actual person we were looking for, and then find the name, and so on. And we could do this with the other example as well. So this is very explicit, and it's not really a nice interface. This is just 1 or 2 levels. If you want to access something 7, 8 levels down into the graph, this gets really tedious. So we looked at several approaches to solving this. And one of the things that kind of inspired us was the whole functionality that MongoDB has, the populate. So in MongoDB, you could say that I have a collection of strings here, which are just references to other collections or the same collection. And then you could say that I want to pull out this, this item from the database, and I want it populated. So you could say that I want all of the stories here on a person to be populated from the story collection. So this would be okay if you were going to do this just a single level, but if you were going to do this recursively, that doesn't work very well. And we also didn't have the luxury of being able to use something like MongoDB. And another thing is that we really wanted this thing to be schemaless. So if we had a person object here, that contains just some metadata, and then we could say that, yeah, this person has authored a set of stories, and he has read the set of stories. But we might at some point want to add another field that they have liked a set of stories, or at some point, you might want to say that, yeah, we want to have, every person is supposed to be able to make their own list of stories, and then they can refer to a set of stories there as well. So that this schema might change at any point in time, which would make these having schemas at all very hard. So our solution to this was to just go for these naming conventions. So an object here containing a story is authored by a person. And person here refers to the people collection. So we just said that if you find a key that has a pluralized version as a collection, just try to look up that reference, and then we want that to be accessible, so that we want to go from a reference here to an actual object that you can access deeply. And then, again, stories here links back to the stories collection, which could then be populated with itself and so on. So you could think of this as an infinitely recursive graph. And the first thing we did was try to do this naively with something like Object.assign. So the code here isn't important, but we tried to solve this using Object.assign, and then to create some sort of interface here where we could say, I want to have a method called populate, which I can pass some sort of depth. How long do you want to be able to access this graph? How deeply? Pass the graph itself, which is just a JSON object with a set of JSON collections. And then we could pass an object that we would want to be populated against this graph. So now we could say that I want to have a populated person, which I want to be able to access 3 levels deep, and I'll pass it the graph, and I'll just pass the first person of the people array, or the people collection, because that's the object that I'm interested in. And this actually works pretty nice. So if we access this object now, or we pass this into the populate method, it'll do this. But if you try to do this more than, say, 4 levels, everything blows up, because this just grows exponentially, right? You wouldn't be able to do this. We want to, let's say we wanted to be able to access this infinitely deep. Of course, that's going to take infinite amounts of memory. And it's going to be insanely slow, and it's just a very naive approach to try to solve this. But it would be so nice if that just worked. And this is where you could use the power of proxies. Because now we could try to implement the same thing here using proxies. And that's what we did with the exact same API. So instead of instead of this now being the depth that this is being populated, it's sort of more like a maximum depth for some reasons that I'll show later. But it's the exact same thing. And now this works exactly the same way, except you're able to do this infinitely deep. And the reason for this is that imagine that we have these two collections here. So stories and people here represent the graph. So the graph is just two collections that are in some ways linked to each other. So if we try to access the first story here, and we want to access the person, and because we want to go into the author of the story, and we want to go in and see what is the first story this person has authored. Whenever we try to access the person here, instead of us eagerly populating and making an insanely large object, with proxies we could just implement this as a jump. So whenever you try to access this property, it just jumps to the object in the people collection. And when you try to access stories from there, it just jumps back. So you could access this infinitely deep. It seems like this is an infinitely recursive big object, but you're just jumping. And that means that you can do these things. You could just access things infinitely deep without actually creating infinitely big objects. Let's see. Yeah, so that's what I mean about proxies being lazy here, because when you create a proxy, let's see. No. When you create a proxy like this, with the Object.assign version, you're actually doing this eagerly. You're creating this insanely large object that is returned to you, but when you're using proxies, you're just wrapping a proxy around, which is lazy, so nothing happens until you actually try to access something on the object. But the caveat here is that if you don't set a limit to the depth and you try to stringify this proxy, it's going to just blow up, because that means that it's going to recursively access any property that the object has. So if you want to be able to stringify or at least serialize this in some way, you'll have to set a limit of the depth that this is going to be populated. But otherwise, it works exactly the same. And for the consumer, there is no difference between how you use this proxied version and the Object.assign version, which is the important part. Sorry about this. So this made us really happy, because now we were able to use this really nice way of accessing the graph very deeply, and we didn't have to pay any performance costs by doing it. And the other nice thing is that since this data was real-time, we just always had a representation of our data real-time as JSON. We didn't really need to do anything fancy. We just needed to update the references correctly. We didn't have to think about this actually being a graph. It's just JSON, everything's serializable. So once we figured this out, I figured, why not try to use proxies to solve all of the problems in JavaScript? So I was going to try to fix this. Undefined is not a function and cannot read property undefined of undefined. So I scratched my head a while trying to do this. So I figured, why don't we just redefine what undefined is? We'll make ourselves a new undefined here. We'll say that undefined is a proxy of just an empty function. And I'll say that if you try to get something, because the nice thing about functions is that functions have properties, so they kind of look like objects. And if I define a getter trap on this proxy, I could say that in any case, if you're trying to get something here and it's not the name of the function, I'll just return another undefined proxy to you. So just recursively returning that to you. And if you try to call this as a function, I'll just return undefined to you again. So I could now make myself a function here that I chose to call Seatbelt, where we return a new proxy. So we're wrapping an object in seatbelts here. And we are returning a new proxy of that object, where we have this getter trap. And we can say that the first thing you can do is just get whatever you're trying to get from that object. Then we could say that if whatever you try to access is an object, we'll just return a seatbelt version of that object to you, so that it's recursively doing this seatbelt thing. Otherwise, we'll see that does this property exist? If it does, we'll return that actual property to you, meaning that this is a primitive type. So if it's I see that this is not actually going to work now if it's false or the number 0, and for certain cases. But just imagine that JavaScript wasn't insane. So if the property doesn't exist, we'll just return our new undefined definition. And now I can make myself an object here, which I call never undefined, which is a result of the seatbelt function where I just pass some simple object here. If I try to access never undefined foo, that has the value bar. If I try to access the nested object here, that has the value 10, and so on. So the object works exactly like it did before for any field that is accessible. But what if I try to access a field that doesn't exist, and then try to access something that is not a function, call that as a function, and then access something on that again? In this case, this is just a function. This is just our new undefined. So this doesn't actually crash anymore. So you can do things like this, and it doesn't crash anymore. No errors. So I feel like this is, yeah, I solved all of JavaScript's problems. But there's one thing that I have not figured out yet, and that is how I can do this. What if I could just replace the object prototype with this, and this would just be completely transparent? So I think that this is probably like my next ambition here. So all of this that I've shown you here now is, of course, just fully abusing proxies. And these are examples of the things that, this is an example of the things that you shouldn't do with metaprogramming. Because what you're doing here is changing how the language works so much that it's not, at some point, recognizable anymore. And that's usually what they call the curse of Lisp as well. Because when you start building a program with Lisp and use a lot of metaprogramming, that program it's going to have so many macros and so much metaprogramming that it's kind of a language on its own, which is really the thing that can go wrong with using metaprogramming. So the really good things about metaprogramming is that you can create these really powerful abstractions. And you can, for the fundamental operators, you could get things like laziness, so that you don't have to, you could do a lot of this with just regular higher order functions or other types of abstractions here, but in this case you can do it for the fundamental operators, so that all of this is transparent. But the really bad things about this is that you might introduce a lot of magic. And you might end up making, especially if you use macros as well, that's going to be your own language at some point. And there's also performance So with a star here, because we use proxies to get performance on the interface that we wanted to build. But proxies themselves are a lot slower than just regular functions and objects and so on. But in this case, it made something that was impossible possible because of how proxies work. So the main takeaway from this is that you should imagine what would be the perfect interface to interact with this, to consume this, and then try to build it. Instead of just being content with what's available in the language. So that's about it, I guess. I see that I have like 10-15 minutes left, so if anyone has any questions, I can do them either now or afterwards, I guess. Yeah?
One of the problems I've run into in trying to think about how to use proxies is that there might be a function that I can't change its code. It's returning an object, and I'd like to create a proxy for that, and then I can, of course, but other things might have gotten a reference to that object already. I have no way to make them use the proxy.
Yeah, that's the issue that you saw with the observable as well, right? Because with that version of an observable, you aren't able to observe something that you haven't created. So that's an issue. So I see that someone solved this by overriding prototypes, and let's say that they wanted to proxy the console log function. They overwrite the console log in the beginning of their application. So that feels really hacky. So yeah, that's one of the limitations, I guess, that you'll have to work around in slightly hacky ways. I haven't found any good ways to solve that, at least.
Are your slides available anywhere?
Yes. They are at, let's see, I can press escape here. Let me see. So if you go, it's slides.com, Eirik LV. I'll see if I can maybe get it a bit bigger here. Let's see. Yeah, so all of the code as well. So the whole graph population thing is something that we're open sourcing because we think that it's a really interesting idea, and we didn't find anything that really did the same thing. And we're also trying to implement this with the JSON API spec so that you can get automatically, if you have a huge amount of like JSON API with links, that also is something that's just populatable, so you can access it deeply. So I guess this also kind of overlaps with what all the graph databases are trying to do now, or like GraphQL at least. So yeah. Yes. Yeah. Yeah, that's you mean if I wanted to override how JSON stringify accessed it, or?
Yeah, so when JSON stringify calls the getter in my proxy, do this thing, but if anyone else calls it, do something.
Yeah, you can do. I don't have the link right now, but you can do some pretty insane things by using the with statement and proxies, where you can then you can sort of get the things that the first question asked about working as well. But it's a bit edgy. But yeah, some people are doing pretty insane things with proxies. So yeah, passing some kind of context, or at least because what you want to do is be able to proxy all of the globals in JavaScript. I want to be able to proxy object or object prototype, and not have to pass that further on. Kind of like you want to be able to overwrite all those things, or at least, yeah, proxy them. So I think that is like the next step of this. Yeah.
Yeah. So one of the solutions, this was already quite nice, but is it possible this reflect get methods and so on? Is it also possible to know if an object is proxied or not, or is it?
That is. I'm guessing that I actually haven't looked into how you can do that in code in that sense, but I know that if you go, for example, into the console of Chrome, you can see that this is a proxy. So there is a way to override this. It's just that it's the benefit of proxies from the consumer perspective is that it's transparent. But I'm guessing that there is, just as you could access the __ proto in most of the JavaScript engines, there is a way to do this in with proxies as well. But I actually don't. I actually haven't figured that out yet. But yeah, that would also be helpful. Yes.